Public key cryptography or asymmetric cryptography is a cryptographic system that uses pairs of keys, public keys which are made public and private keys which are known only to the owner. The public and the private keys are related and there isn't a known way to generate the private key from the public key. Data encrypted with the private key can only be decrypted with the public key and vice versa. In such a system, any person can encrypt a message using the receiver's public key, but that encrypted message can only be decrypted with the receiver's private key. For example, if I want to send you an encrypted message, I need your public key to encrypt the message. Being encrypted with your public key, the message can be decrypted only with the private key of the key pair, and you are the only person that possesses the key. Note that the length of keys of asymmetric encryption algorithms are much larger than the length of the keys of symmetric algorithms without being more secure. For example, an AES key of 128 bits and an RSA key of 3072 bits both have a similar strength. You cannot compare the key length of symmetric and asymmetric encryption algorithms easily. Let's get started with a hands-on example. To make it crystal clear, I'll start it from scratch. There are two users that want to exchange secret information or files and they will encrypt them asymmetrically. Symmetric encryption is not viable because there is no secure way to exchange a secret, a shared key. Each user will generate a key pair, keep the secret key private, and publish the public key on a public key server. Let's generate the key pair for each user. GPG --gen -key. I'll use a passphrase to lock the private key. Perfect. And I'm publishing the public key to pgp.mit.edu key server. The last lecture was all about key servers and distributing the keys. Take a look again if you feel the need. Let's see the key ID. GPG --list keys --key ID -format long. This is the key ID. I'll use it to publish the key on the key server. So GPG --key server HKP, this is not mandatory, :// pgp.mit.edu -send -keys and the key ID. Okay, it's PGP, not GPG. Sorry, PGP. Perfect. The key was sent. And I'll do the same for the second user. Each user needs its own key pair. Now I'm generating the key pair of the user and publish the public key on the key server. Okay, at this moment, each user has a public and a private key. The public key is on the server and the private key is kept secret locally. The next step is to import the other user's public key in the GPG keyring. This is necessary if you want to send encrypted files to the other user. Of course, if only the first user will send encrypted message to the second user, then only the first user needs to import the public key of the second user. In this example, only the user on Kali will send encrypted message to the other user, to this one. To import a public key, you need either the public key in a text file or the key ID to download it from the key server. Of course, if it was published there. In this example, the user on Kali will import the public key from the key server. To do that, the user needs the key ID. We suppose he has received it by email or by any other means. This is the key ID. So GPG --key server pgp.mit.edu --receive recv and the key ID. Okay, the public key of the second user was imported. Note that it needs some time for the server to synchronize after receiving the key. So after sending the key, you must wait a minute or two until you can import the key in another terminal or on another machine. If you don't have the key ID, you can search for a key by the owner's name or email address like this. --search -keys and a string to search. Let's take the user's email address. And it found the key. This command will print a list of matching results and you enter the number next to the one you want to import. I've already imported the key, so I'll press on Q from quit. Let's list the public keys in the keyring. GPG --list -keys. Okay, there are two public keys, my own public key and the other user's public key. Let's move on and encrypt a file for the second user asymmetrically using the public key of the second user. Let's see the key ID. Okay, and I'm writing GPG -e from encrypt. You can write -c or --encrypt, it's the same. -r and the recipient's key ID. In this case is the ID of the second user's key. And the file I want to encrypt. I'll create a new file in another terminal here. Yeah, in the GPG directory, I'm creating a simple file, let's say secret information and an output redirection. For example, message.txt. Okay, this is the file. So message.txt. And it wants me to confirm that I want to use that key. This warning is normal in this case. In the same directory, a new binary file has appeared, message.txt.gpg. This is a binary file. It was asymmetrically encrypted. If you want to encrypt and store in ASCII format, you must add --armor or -a option like this. -a from armor or --armor, it's the same. And the encrypted file resulted is message.txt.asc from ASCII and is a text or ASCII file. This is the file. Note that both binary and ASCII versions decrypt the same way. Now the user will send the encrypted message to the other user on an unsecured channel like the public internet. In this example, I'll transfer the encrypted file to the second user using SCP. SCP uses SSH and it's an encrypted connection, but I could also use an unencrypted one like HTTP or FTP. I'm using SCP only because it's already set up and it's working. I don't want to set up an FTP server for that. Let's see the IP address of the other Linux machine. So SCP, the encrypted file or files. I'll copy both encrypted files. The name of the user on the other machine, student, and the IP address. And the local path where to copy the files in its home directory. Okay, there is an extra 0. It was a typo. Okay, this is the correct address. And the user's password. And the encrypted files were copied. These are the files. The recipient has the encrypted files and wants to decrypt them using its own private key. He's the only person in the world that has the private key, so only he can decrypt the files. And he runs GPG -d or --decrypt and the name of the encrypted file. Let's take the binary one, this one. It's asking for the passphrase that will unlock the private key, and I'm entering the passphrase. And we see the contents of the file. Secret information. This was the contents of the file. This command didn't create a new file. It printed out the file contents at the terminal. If you want to create a new file, you can simply add -o from output and the name of the file. For example, message.txt. The file was decrypted and a new file was created. The other file, the ASCII one, decrypts the same way. I'm overwriting the file. That's all about asymmetric encryption. Thank you.